Hey there! Turn on your speakers. Do you have finals week coming up? Projects due? Homeworks are piling up? Are you freaking out that you're getting boxed in with deadlines? Here's an idea. Get help. Think Geek Exams. Find us on Facebook, Twitter, or YouTube.
Hi, so this is the statics homework number 11.3. This has to do with a ball socket, a bar, and some strings, as you can see in this picture. So this describes a problem here. There is a ball socket here, BS. There is a bar here from O to A, and there's a force that's coming downwards at 505 newtons in the negative K direction, and there are two strings that are attached to points B and C. The coordinates of A, B, and C are given, and the force F is being applied in the midpoint of O and A. So these are given. And we're told to find the tension in AB and AC. And we're also told to find the reaction force at O. So let's talk about the what's known. As we talked about already, we know the positions A, B, and C. We know because we know A, B, and C, we know that ROA, the vectors of the forces that are, so basically the positions where the forces are being applied. And their vector position from O over here is ROA and ROD. Those are the only two vectors. The other one is ROO. It's not trivial. We don't need that. So the directions of the forces are U of F, which is minus K direction, and U of AB, which is the direction from here to B, and the direction vector UAC, which is from here to here. And they can be calculated by subtracting OB minus OA and dividing by the magnitude, and OC minus OA and dividing by the magnitude of the difference. And that's what's described over here. We also know that the magnitude of the force is 505. We also know, another thing that we know is the number of forces being applied on the bar are 4, and they are the F, force F, and the tension AB going from here to here, and tension AC going from here to here. And there's the reaction force RO that's being applied at the ball socket position. So those are the forces, and only F is known. Everything else is unknown. So we are being asked to find the tension in the string AB and the tension in the string AC, and those are scalar quantities, directionless. We just need to know the magnitudes. And we are told to find a vector RO. So this is a 3D vector. It's going to have 3 components here. So there are 3 unknown quantities in this vector that we need to figure out. All right, going on to some equations. So let's lay down some equations. So first thing we want to do, I'm going to do this in a slightly reverse order because I think it's helpful. So usually I take the sum of forces first, but today we're going to take the sum of moments first because that's going to give us the tensions. So the way you calculate the moment of a force is getting the cross product of the position of the force compared to the point where the moment is taking place. So we are doing moments about point O, so we need the position vector ROA for TA. So cross product is going to be ROA crossed with TAB, right? And we have another one which is AC, so TAC. So the cross product for that is going to be ROA crossed with TAC. So that's moment of this force and moment of this force. And then lastly, there's one last force that has a moment, which is the F force. So for that, it's ROD. So we're calling this point D. So ROD cross F. So those are the three moments that equate to 0. So there, the thing about a ball and socket joint is it doesn't provide any reacting moments. So basically, it's free to turn around that ball. So it doesn't have any moments to speak of at that point. So we can add these 3 moments and make it into 0. And so over here, we basically want to take out the knowns and the unknowns. The TAB, the magnitude of TAB is unknown. Here, this is a vector, so this has the direction component of it, but we know the direction. The direction is UAB, and we already calculated that. So we can take the direction out and the magnitude out of this in a parentheses. So basically ROA goes here, and only the unit vector remains here, because if I multiply TAB with UAB, it's going to be TAB vector. So this allows us to separate the unknown here with the cross product. And we do the same thing with TAC over here, and we take the ROD cross F to the other side. So if we solve this equation, it's going to give us TAB and TAC. So that's good to know. Now, after we know TAB and TAC, what we can do is we can add all the sum of the forces, F, TAB, all the vectors, and R0, TAC, all these vectors, if we add them, they are going to be 0. So from that, we can basically calculate RO. RO is basically negative of the sum of the rest of the 3 forces. And the thing about it is TAB times UAB is going to give us the vector of TAB, and same thing with TAC times the unit vector of UAC is going to give us the vector of TAC. So if we know TAB and TAC and F and the unit vectors, we can find RO. So that basically is the way we're going to solve this problem. So let's look at the Matlab. The Matlab is, we're going to do this in the next video because we're going to run out of time. So we're going to continue this in the next video. So now we go into Matlab, and so first thing we do is we put in the positions of A, B, and C as we saw them in the question. So and then D is just A over 2. So basically the position of D is A over 2. It's a midpoint of OA. And then we basically say the ROA vector is just A and ROD vector is just D. So that's trivial as well. And here's where we calculate the UAB. So we basically subtract B from A and we get AB. And we basically divide AB by the magnitude of AB, which is norm of AB, and that gives us UAB. And same thing with UAC. It's basically the same idea. So the blue part is UAB and the green part is UAC. All right, now that we have UAB and UAC, and we also have ROA and ROD, we can basically take that equation, the equation that we had, the vector equation from the moments, TAB, ROA cross UAB, and we can basically calculate these portions of it, ROA cross UAB and ROA cross UAC, and we can also calculate what ROD cross F is going to be. So those numbers are calculated in Matlab over here. Our ROA cross UAB is over here. That's this one. ROA cross UAC, that's this one. and our OD cross F, that's this one. All these numbers, I just got it from here, and this is negative ROD because that's a negative sign over there. I calculated the positive and I wrote down the negative here because I need the negative here. So that's how you calculate that. Once you calculate this, you can drop, okay, we'll go to the next slide for that. So once you calculate these three over here, you can drop the zeros. So you see the first element of each of these are zeros. So we can drop those and make this into a 2 by 2 matrix, where this is the first column, this is the second column, and this is the resultant vector. So that looks like this. This is our matrix. If you multiply that by TAB and TAC, you should be able to get this number. But we do not know TAB, TAC, so we basically take the inverse of that matrix, multiply that by the result that we expect, and we should get TAB and TAC. And that's what we did here. So we defined the matrix A as the last two elements of ROA cross UAB, and then the last two elements of ROA cross UAC, and we put them in each column. And then we defined a Y as the negative of this vector over here, which is minus 1,515, and then 0. And then we do this calculation over here, where mat A is inversed, and then a matrix multiplied with the vector Y, and that gives us a T of 289 and 169. Those are our TAB and TAC numbers. They are in blue. All right, so moving on. So now that we have TAB and TAC, we can basically get the sum of forces done. So we have F as a vector, and then we have TAB and TAC as numbers, and we also have UAB and UAC, the direction vectors. So we can just multiply the direction vectors to the magnitudes and get the vectors, and then add it to F, and that should give us RO. And that's exactly what I did. So from TAB is the first element from T, from the previous, so this one, and TAC is the second element from here. So that's what I did over there. TAB and TAC are over here, and then I'm basically getting just like this equation looks like over there, minus in parentheses F plus TAB times UAB plus TAC times UAC. That's just this equation right there, and that gives us an RO in a vector form which has three values like we predicted. It will have I, J, and K values. The J value is 0 because it's negative 0 is 0. So that's what we reported over here, and that takes us to the answers for the question. TAB and TAC are over here, and RO is over here, given in vector form, in IJK form, and it looks like the answers were correct. So thank you very much. See you next time in the next video.
Think Geek Exams. Our agents have Masters of Engineering degrees from MIT, Stanford, Georgia Tech, Caltech. We give you solutions to mathematics, physics, computing, and engineering. Find us on Facebook, Twitter, or YouTube.